We've come to part 3 of graphing linear equations, and we're finally going to do some graphing. So the first way we'll learn how to graph a linear equation is by finding its intercepts. Intercepts are where it hits one of the axes. The x-intercept is where it hits the x-axis. The y-intercept is where it hits the y-axis. So the x-coordinate of the point at which the graph of an equation crosses the x-axis is an x-coordinate, x-intercept. Intercept means crosses paths. This is the same root word we get intersection for. That's where two roads cross each other. And to find this value, we just plug in 0 for y and solve for x. As you'll see once we do it, that finding it is pretty straightforward. When you want the x-intercept, plug in 0 for y and solve for x. Now the y-coordinate of the point at which the graph of an equation crosses y-axis is a y-intercept. So just remember, the x-intercept is the horizontal one, the y-intercept is the vertical one. So where I hit the y-axis is the y-intercept, where I hit the x-axis is the x-intercept. So to find the x-intercept, plug in 0 for y, solve for x. To find the y-intercept, plug in 0 for x, and solve for y. So whenever you want something from the x, treat y like nothing. Treat it like 0, solve for x. When you want something from y, treat x like 0, and solve for y. So graph 2x plus 4y equals 16 by using the x and y intercepts. Now often when the book or quizzes or tests ask us to do this, it will be in standard form. But that's not required. They could give this equation to you in any form they want, and you could find the x and y intercepts. So first, to find the x-intercept, we just follow the directions it says right here. Plug 0 in for y and solve for x. So we look at this equation. I plug 0 in for y. And then I'm trying to solve for x. Well, 4 times 0 is 0, so that term just disappears. I get 2x equals 16. Then I divide both sides by 2, and I get x equals 8. So that means my line will hit the x-axis at 8. So 5, 6, 7, 8. So I know that's one of the points on my line. Now let's find the y-intercept. To find the y-intercept, we do the opposite. We plug in 0 for x and solve for y. So I plugged in 0 for x. 2 times 0 is 0, so we get 4y equals 16. Divide both sides by 4, and I get y equals 4. So that means my line hits the y-axis at 4. 1, 2, 3, 4. Once you have 2 points, you have all the information you need to draw a line. So you need to draw a line between those 2 points. You can use a straight edge if you want to. Make sure when you draw your line, you do put arrows on both ends to show that the line goes on forever and ever. So connect the 2 dots that you draw, the 2 points, and put arrows on both sides of the line. And now you have graphed an equation. Let's follow the same steps here. They give us an equation and they say graph it using the x and y intercepts. So to find the x-intercept, I plug in 0 for y. 4x minus 0 is 4x. Divide both sides by 4. I get x equals 1. So the x-intercept, where my line will hit the x-axis, which is right here, is at 1. Now I'll find the y-intercept. To do that, I'll plug in 0 for x. 4 times 0 is 0. 0 minus y is negative y. So remember there's an understood 1 right here, so that's really negative 1 times y. So I can divide both sides by negative 1 to find that if negative y equals positive 4, positive y equals negative 4. So my y-axis, where it hits the y-axis, is the y-intercept, is at negative 4. This one's pretty steep. So I'm going to go and draw my arrow connect the lines, draw an arrow on the other side. Because once you have 2 points, you have enough to make a line, draw arrows on both ends, and you've done it. So that's how we use x and y intercepts to graph an equation. But believe it or not, there really are lots of ways in the real world that a linear equation can do a good job of modeling what's going on. So we're going to use this time to talk about how do we interpret what an x and y intercept would mean when that line is actually representing something in the real world. Well, x-intercepts tell us how much of the x variable is present when the y variable is equal to 0. So let's go ahead and look at this graph. We'll discuss it again once we do this problem, but the x variable is always what's down here with the x-axis. So for this graph, it's time in minutes. The y variable is always the one that's along the vertical, the y-axis. In this case, it's dollars. So for this example, our x variable is time, minutes. Our y variable is dollars. Y-intercepts tell us how much of the y variable is present when the x variable is equal to 0. When you're dealing with time, this is also known as the starting amount. So if we're looking at something over time like we are here, the y-intercept tells you how much we started with. Make sure you guys got these. I'll pause there for a moment. Okay, so our first thing they want us to do is know how to find the x and y-intercept on a graph. So we figured out how to find the x-intercept and the y-intercept using equations on the previous one. Now we're going to find them on a graph. So remember, the x-intercept is where our line, which is this right here, hits the x-axis. So that's 20. Our x-intercept is 20. The y-intercept is where our line hits the y-axis, so that's at 30. Now, this is a true answer. This is good for the x-intercept and the y-intercept. If it helps you with the interpreting, this as an ordered pair would be 20, 0. Because you go over 20, but then you don't go up or down, so your y value is 0. This one would be 0, 30. You don't go left or right, you just go up 30. Now I show you that because that might help you connect it with how we did it with equations. We found the x-intercept by plugging in 0 for y. We found the y-intercept by plugging in 0 for x. So here's what happened. I didn't write this out in the notes for some reason, but someone went to an arcade. This represents how much money they had over the amount of time they spent there. So this shows the amount of money someone had as they were at an arcade. So what does the x-intercept mean in the context of this problem? Okay, so the x-intercept is right here. The x is minutes. So this is minutes. So 20 minutes. The x-intercept happens at 20 minutes. And it tells us that at the 20-minute mark, their y value, their dollars, were 0. So that means they had $0 after 20 minutes. Now you can say this more than one way. You could say, after 20 minutes, they ran out of money. How'd you find if you just said, after 20 minutes, they were broke? Or you could just say, they had $0 at 20 minutes. You could also say they spent 20 minutes at the arcade and they spent all their money during that 20 minutes. Anything along those lines, just trying to make sense of the fact that there's no money left once you hit the 20th minute. Now, what does the y-intercept mean in context of this problem? So the y-intercept is 0, 30. Remember, x, 0, represents minutes. So that's when they arrived or when they started playing. So at the beginning, when they arrived, they had $30. Like I said here, when dealing with time, this is also known as the starting amount. So you could also say when they went there, they started with $30. So you'd be fine just saying they started with $30, or you could say when when they arrived they had $30, anything like that. I'm just going to say they began, because that implies the time is 0 right there, with $30. So they had $30 when they started. 20 minutes later, they'd spent all their money. That's what this graph is really showing. When they started, they had $30, and over 20 minutes, they spent all their money at the arcade. Okay, one more example on that. Just like we want to find the x and y intercept on an equation, on a graph, we want to be able to find it with a table. This is a table. So a swimming pool is being drained at a rate of 720 gallons per hour. The table shows the function relating the volume of water in a pool and the time in hours that the pool has been draining. So here we are. This is the volume of the pool. This is the time it took them to drain it. So it says find the x and y intercepts of the graph of the function. So this is another reason I made a point to show you the ordered pair. You don't have to tell me the ordered pair when I just say what's the x-intercept or what's the y-intercept. You can just put the 20 or the 30. But I knew this was coming on the table, so I wanted to show you this. So if you remember, to find the x-intercept, we plugged in 0 for y. So the x-intercept happens when y equals 0. So the x-intercept, this is an ordered pair, is at 14, 0. The y-intercept happens when the x is equal to 0. So the y-intercept happens at 0, 10,060. You can put a comma in there if you want to, but to me when you have an ordered pair it makes it confusing to have 2 commas, so that's why I didn't bother. So now we're supposed to describe what this means in the context of the situation. So the x-intercept, remember what x and y represent. X represents time in hours. Z represents the volume of water in the pool in gallons. So the x-intercept means that after 14 hours, there were 0 gallons of water in the pool. And you can say it like that if you want to, but I think a more practical way to say it would be it took 14 hours to empty the pool. That being said, if you want to say it more formally, like after 14 hours, the pool had 0 gallons of water, I would certainly accept that. That's fine. So the x-intercept means it took 14 hours to empty the pool. Now the y-intercept says when their time was 0, meaning at the beginning, there were 10,060 gallons in the pool. So you could say something like the pool started with 10,060 gallons of water. So as I said earlier, the y-intercept is often telling you the starting amount. They started with 10,060 gallons of water in the pool, and after 14 hours of draining, the pool was empty.